Welcome to the video. Today we will be solving the bigger is greater problem. This is actually not the first clip that I recorded. I actually recorded a good 40-minute clip of me solving this problem, only for it to not want to work in my editor. And the other clip that I have posted is over 2 hours long, so I figured the 2 hour long clip is probably plenty enough footage, so we're kind of going to start from halfway through. I guess the main things about the problem, honestly, I don't think there's anything special that I did with bigger is greater than I did some research to understand what lexicographical order is, how I determine it, and then I basically literally just went straight to programming a solution. So, hope you guys enjoy. Alright, so it's another day, and I think I might have came to a solution, but I don't know. I'm thinking maybe maybe a left pointer, right pointer situation is where to go. So left pointer equals 0, right pointer will equal w dot length. I sat through here and I worked through all the different things you could do if you had the data sorted and things of that nature, and I asked ChatGPT hey, what's the most efficient time complexity? Not the answer itself. But after looking at it, there's nothing I can really do, I think, with. So instead, I'm thinking possibly a 2-pointer. And that's just completely, I'm guessing. I have no idea whether or not I'm right. So, we'll see. Dude, it's so weird going from Python, where you have to declare the type, or from JavaScript, where you have to declare the type of variable, like let, const, var. And you have to declare its type, to Python, where you give it a name and you give it a type, but you don't say, well, you don't type explicitly, you just give it passive data. It's crazy. I think I'm on something. Or maybe I'm not. Right index is out of range. What are you doing, buddy? You wanna play with the toy, huh? Alright. I guess I'll take it. Alright, so I'm gonna run. Oh wait, I already ran this and it had an error. Line 21 is out of range, and it's because right index should be probably -1. Why is left pointer instantly out of range? Wait, what? No, where's left pointer at? Right pointer +1 should be -1. What do you mean it doesn't support item assignment? Are you really gonna force me to slice this string? Why wouldn't a string support item assignment? I feel like it's such a basic thing. What in the fuck? Whatever. Start from here, I guess. Indices must be integers or slices, not strings. Ri is a string. It is in fact a string. Why would I do that? I don't need the value of this. I just need the index. Right pointer is out of range. Wow, I'm trash at this. This is pissing me off. How can... Why does it keep doing that? Oh my god. would take away all these yellow caution chips. Really piss me off. Left pointer equals right pointer. Why would right pointer be out of range at this point? Right pointer is equal to the right index. Right index. Why do I have... Jesus Christ. Okay, this shit's so disgusting. I'm getting rid of this. This is actually getting on my nerves. I don't know why I made this as difficult as I did. Right index. No, we're going to do a right pointer first. The right pointer is equal to the length of W minus 1. The right index is equal to the right pointer. The left pointer is equal to the right pointer minus 1. The right index, or left index, is equal to the left pointer. That's it. While the left pointer is greater than... No, while the left pointer is greater than 0. We will say if the value of W at the right pointer is greater than the value of W at the left pointer, then we will want to should I be starting reversed? I think in theory, the first time that I'm able to make one of these swaps, I can break and return. W, okay. Left value is equal to W at the left pointer. The W at left pointer is equal to W at the right pointer. W at right pointer is equal to left value. And return W. But I can't just return W because W is in a list and it wants a string. W at the left pointer is greater than W at right pointer. No, right index. W at right index. No. Right index is equal to left pointer. Right pointer plus equals 1. Right index, no. Left pointer plus equals 1. So what is the situation? Okay, so I think either way I'm going to need this. What is your problem? Wait, so I just did a return at any point? Damn. The only one that failed was the last one. So we got DKHC. And I think what? C should be the one that replaces it. So it should be... Oh. What? Is H greater than... What is it? H is greater than D? It's good to see that I'm like close to a solution. It almost makes me feel like I'm in the right direction. But then again, there's like just a little bit of a weird flow that's hard to control. Lemon. Okay, so I got another one wrong. A, B, C. And the K swaps the C. Yeah, that's like a weird flow. This is like the point where my program definitely breaks down and where I'm struggling to see a solution. All right, so I asked ChatGPT if it was even solvable using a two-pointer method, and it said yes. I hope you guys aren't going to consider that cheating because all it does is steer me in the direction that I need to go, but it doesn't exactly mean that I know the solution. Matter of fact, I'm struggling pretty bad to understand this one because, like, here's the thing. So take a look at these two different examples. If we have DKHC, the solution is HCDK. And the solution here would be CBKH, I think. Here's what I'm not understanding is if you're using two pointers, there doesn't seem to be a rule. Like if you look at these two, we had to make sure both of these work, right? In this one, the way that this would go is you want to swap the first element and the last element, right? And in this one, you want to swap H and D. And I'm not seeing a solution that'll basically allow me to consider this letter long enough for it to be swapped here. Because, like, you could do something along the lines of, okay, I'm going to keep track of, dude, I don't even know what you would do. Like, there's nothing I can see. Because, like, if you try to keep track of, like, the minimum number, C right here would be the minimum number, you would get all the way through the array before ending at D. So, like, you would consider, you know, C, and then H, K, D, and C is like you would stay on C, and then your last pointer would end up at D. And you could say, okay, I'm not seeing a solution for any of those. So let me pull my right pointer inwards, and eventually you'd hit H, and I would swap it. But here, that method actually kind of gets pretty close to working, I'd say. But, like, what happens if you have something like, that's H and D. Let's make H, okay, let's make this E, K, D, C. Wait, no, this is like the same exact scenario, is it not? No, it's not. It's not. So, what, C would be, okay. So this, how do you consider this, right? I think I wanted to put the C here and then the E at the end, I think. I forget what I was trying to do here. Whatever, let's try this. If you tried this, C will get all the way through without hitting anything. So you'll basically push the left pointer down to the end. If you try D, you'll get all the way to the end. Okay, so I want to swap E and C. Okay, so if you did that, C would make it all the way through, so your left pointer would end up at the end there. Your right pointer would still be down here. Then you can move over and you can try D. D's not going to work. You could try K. K would work. So if K would work, then you could say, okay, so see, that's the thing. So now if K would work, then we could say, yes, we could try swapping those, but maybe there's a better solution, so let's move further down back this way. But now you're considering K and C, and that's not as efficient as D and C. So how do you know to consider, well, like, how do you know to stay at D? I mean, I could pull a solution where, you know, I iterate multiple times, like, at the input, but there's an O of N solution here. Because, like, obviously, I could go to C, I could consider everything past C, and then I could go to D, consider everything past D, consider K, you know, whatever. But that is way worse than O of N if I'm not... Yeah, that's way worse than O of N. I think that's an N squared solution or a N log N solution. So I really don't know what to do here. This is a very good test example, though. I should really keep a hold of this. Wait, am I trying to say that D is supposed to overtake E? Because that is definitely not the case. Alright, my girlfriend's texting me. Guys, I fucking hate to ever accept defeat, and I'm really gonna try not to, but this problem, I've been staring at it for like 2 hours now, and it's just not going my way. I mean, I created like a test scenario to try to understand this. And like if okay, so if you were to do something along the lines of, okay, let's make our left pointer B, our right pointer A. You see that A is not bigger than B, so let's just basically move the left pointer until we find something that A is bigger than. Well, we find nothing, and we also end up at the we've already iterated through all of our input, which means that that's already an O of N solution. So we should have been able to do it on that first pass. So doing it that way can't be a solution. So doing it something along the lines of, let's look at B and A. Nothing is bigger. So A is not bigger than B. So let's push the pointer down to here. Let's look at C. Let's see if anything's bigger than C. We can move our right pointer to B. Nothing's bigger than C. You do the same. See if there's anything bigger than D. There's not. Same with F, I, G, H. Until we get to E, we would be considering E and H. H is bigger than E. And so you know that there's at least one letter bigger than it. And in reality, E is the letter that we need to change, and we were supposed to change that with F. But I'm not seeing a behavior that would basically ever mark F as a significant index. Like there's no reason for F to be significant compared to the rest of these that I'm seeing. I mean, wait, maybe there's something with you keep track of the largest number, and when you finally see a number larger than it, you backtrack. And I suppose that could potentially be less than the input length, but it could potentially be more as well. In a worst case scenario, it could be larger than the input length. Like if E was down here at the end, and you saw that it was smaller than your largest number. Matter of fact, I think I have a test case. No, I don't. Okay, let me make a test case out of this. E, H, G, I, F, D, C, B, A. You would get all the way to the end before you would be able to backtrack. And when you backtrack, you would backtrack all the way down to F. And that was our input plus 5 more. Okay, but it's O of N because I think this is 2N, O of like 2N, which you only consider constants, so or you remove the constants, so maybe that's why that's a solution. I'm gonna try to implement this. I think this might be the solution. But that would also mean that I have to keep like a number score of these numbers values. I guess that shouldn't be an issue because, I mean, yes, I would have to convert them to ASCII codes, but I can literally directly use the ASCII codes. Like, I don't have to do any conversion beyond that point. I mean, it's like, I forget the range, but whatever. Let's just run it. So, let me comment this out so I feel like I have a bit of a blank canvas to work with. I don't know if I'm the only one that, like, really struggles with this. I really struggle to, like, manipulate old code to work with, like, new circumstances. I always just feel much better when I can, like, start off completely fresh from a blank canvas. Alright, so the first thing I will uncomment is this. We'll probably uncomment down to this point. And one thing I want to do is I want to change this to a list of ords, and I don't know if there's a map function. Let me see if there's like a map function. I think it's a lambda. Oh, it does have a built-in map? Function iterable, and it's probably going to be a lambda, yeah. See, I know some shit, just sometimes I struggle to find solutions. Lambda x equals x times 2. Map, and we're going to give it a lambda x, where x is going to be ord of x. Wait, I think I just might have used my first map function in Python correctly. That would be very nice if I did. Right pointer, all of that's correct. That'll be fine. Well, left pointer is greater than or equal to 0. I think that the second that I find a number... Yes, okay, so the second that I find a number smaller than the maximum number, then I should be able to just say, okay, that is the point that I need to swap. Yeah, so I guess the second that you find a number that's less than the maximum number we've seen, then you can easily guarantee that there's a solution there. Or, no, it's and W at left pointer. You know what, I'm not going to control that in the loop itself. I'm actually going to break out of that up here. So the condition I want to check is I want to keep track of a maximum number, which I was kind of doing with the right index thing. It's kind of the point in the whole right index, left index thing, but now that I think it's kind of separate from any pointer at this point. Max val equals what? Left pointer? No, it's the max between, I don't know how to math about max thing. Max between W at right pointer and left pointer. Okay. So we've got that. If the, well, do I even need to move my right pointer? I don't think I do. I think I literally iterate left and then back right. A, B, C, D, F, I, G, H is my max. E is less than my max, so I iterate backwards through it. I don't know that I would consider this two-pointer. I really wouldn't consider this two-pointer. I would consider this finding... Yeah, there's like literally not even a thing as such as left pointers and right pointers. I mean, I guess you could theoretically structure it that way, but it's not like strictly necessary. If W at left pointer is less than max value, then we're going to for sure return something. And see, these are nested, but I think in the way that they're nested, it'll only ever be, it'll still be O of 2n, I think. I is going to be left pointer plus 1 for I in range. Left pointer plus 1 is the start index. W dot length is the, no, length of W is the end index, and I'm stepping normally. What we're going to do is min val. Okay, we're going to say if W of I is greater than W of LP, then we're going to say, okay, so there is a reason to have a left and right index. Right index should be equal to right pointer. Left index is left pointer. Okay, so I think I can get rid of this max val bullshit. I don't know if there's not a reason for a left index. There's a reason for a right though. For I in range. Where is this max val thing coming from? Right there. If WI is greater than W of LP and W of I is less than W of right index, right index is equal to right pointer. So I do want to start my right pointer off at the, so I actually don't need to even initialize my right pointer up until the point that right pointer or my right index up until the point that I'm actually at the element that needs swapped. I almost gave up on this problem, but I think I got it now. Left pointer is equal to, can't be the first one, so it's got to be W dot, no, length of W, God, length of W minus 2. And W of I is less than W of Ri, which doesn't exist. It's less than max value. Okay, but I do need to keep track of the index. God damn it. See, this is a retard. Right index equals none. I equals I. If W of I minus W of LP is equal to 0 and not equal to 1, return left value is equal to W at left pointer. Oh, I can save left value a little higher up the tree, which I guess is still unnecessary. Left value is equal, or goddamn, W of I is equal to left value, W of W of left pointer is equal to I, W of I. W of I is equal to left value. And should be able to return dot join and pass W. What is this? This is unnecessary, is it not? No, it's necessary. So otherwise, we should keep looking. Max values WI, right index. So down here, dot join W, but I need to make a swap first, so I'm going to swap. Literally before this exact process, I don't even think I need to do anything differently. Oh, pussy. Damn, I'm crashing hard after that monster. I'm tired. What? No answer. Alright, well, let's just try this and see how it goes. Okay, Len has no map. Type map? What do you mean type map? I don't want it to be a map. Okay, well, that's kind of an interesting thing. So I guess maps are like JavaScript generators, and when you convert them to lists, you basically exhaust the generator and iterate, or you create every possible iteration. Well, you perform every possible iteration, so it's not inefficient. I guess it's just how this has to go. You learn something new every day. I can't even say that's dumb, honestly. I kind of like how they do that. Wait, no. No, I don't know what happened. Line 57, where is that at? 57. Dot join W, and it doesn't like that? So I think I'm gonna have to do a little switcheroo reversal right here. W equals, there we go. That should do it. But it's good to see that the program like seems to step through everything pretty decent. Line 60 now is complaining because of the same issue, I'm sure. BA, no answer. DHKC, I have no answer on HCDK. And DHCK, the H and the D get swapped. Yep. So left pointer is at 3. It looks at 99, it goes to 2. It gets all the way to the end, and it looks at this one. It says it should say that. Let me add a little print statement in here. Why I don't. Sometimes with those errors, it just pisses me off. Okay, so it's not even entering the loop. If left pointer is greater than or equal to 0, is less than max value. So it's not registering max value correctly. So is max value, where is max value even being saved? I feel like at no point in this do I really keep a good track of left value. Else, max value is not proper .python. Else, max value is equal to W of left pointer. Uno momento. Ah, what the hell? Not none type. How is that even possible? How is that even possible? How could you make it all the way through this fucking loop? BB should be no answer. Maybe. So what's the last one? Fuck me again. It is in fact the last one. And what swap did I make? I made the swap of. Wait a second. DHKC, HC, yeah, is the last one. So it should be H and D. And I did that. How are they different? How? Wait, are you telling me the swap should be between C and K? How the fuck? As per the problem description, I'm supposed to create the smallest possible word with pretty much any swaps. And I found a way to create the smallest word given one swap. I did not find a way to create the smallest word given any amount of swaps, because that means I have to make multiple swaps. So that's something. So basically, it seems that the rules almost change once you make the initial swap. Because like, at first you're looking for the first number that's less than the maximum, because you know that's the first number that can possibly be swapped. But after that point, you're just looking to make the smallest word possible. But I'm also wondering how much of this could you... I'm going to write a solution, but I'm worried that the solution's going to not be very efficient. Okay, so I'm going to have to bring back the left pointers and the right pointers. Dude, this problem is honestly so fucking annoying. I want this to be done with. Okay, so this process right here can be repeated multiple times. No, this can't be repeated multiple times. I just don't know how long... How many of these swaps could you, in theory, make? Okay, so it seems like once you make that first initial swap, you literally can just return the string in order. HKC, but that's not the case for all of them. Okay, so you'd put everything this to the right in order. Okay, so I just need to slice the string beyond that point. But then I need a sorting algorithm, and who knows how efficient that is. It's got to be beyond O of n. Alright, I'm getting another text. Alright, so it seems to be that once you make the first initial swap, you literally just take all of the elements right of the index that you swapped, like the leftmost index, and then you sort that and then return a spliced array from the beginning of the array to the leftmost element that you swapped, and then plus the sorted elements beyond that point. That seems to be the solution, but I'm trying to confirm that now. But none of the test cases that are here are really helpful. So many of these are just so unhelpful. Like, so many of them are just like immediate solutions. I almost feel like they're trying to fuck with me here. Is equal to the up until left pointer, and the right half is equal to left pointer until the end. So that should be fine. And then we're gonna dot sort. Okay, but that's asking about a key. I did not pass anything. Maybe I could just say sorted. And the list of W. Why am I converting W to a list? I don't think there's any reason. Okay, so these don't... Okay, this is unnecessary down here. It's already converted to a list by this point. So it would actually be left half plus right half, and I don't know if you can do array arithmetic with this. Okay, I'm going to try adding this line right here. Oh, man. Left pointer, right pointer. DHKC, so only the last one struggled, and I think it even hits an error? No, it doesn't hit an error. So, plus 1, plus 1. Oh, it should be reversed order. Where did I get that notion that needed reversed? Come on. Please, man, please. This is probably the point where I'm kind of forced to give up. Expected output was no answer. I don't even get to see from the end, find the character that is larger than the pivot character. The first character that's larger than the pivot character. Is that really the way to go about doing that? We don't need to keep this. I think we can completely remove anything referring to max value. W of LP minus 1. So I probably don't need this. Max value, so I don't need this. Don't need this. I'm so scared I just broke this entire program. Well, that would be because the left pointer probably should start here. Okay. Let's try submitting. Let's just see what happens. Wow. Okay. Holy fuck, man. What a fucking problem this was. Jeez, dude. I wonder what was preventing me from seeing the solution when this first began. Okay, I'm not going to talk through this too much. I think this problem was probably easier than I made it out to be, and I'm probably just very slow for taking like 3 or 4 hours to complete it. I know the first time I saw this problem, I gave up. So I'm at least proud of myself for making it through it, and I have gotten better at doing shit like this, but obviously I'm still pretty sad that it took me this long to figure it out. So the solution goes, basically, you move left until you find, okay, so you start at the end of the array, or the end of the string, but we convert it to an array. And, well, I suppose, no, they do it that way, I think. Do they? Whatever. You start at either the end of the array or the end of the string, whichever one you choose to go with. I couldn't tell you if one matters or not. And you move left until you find an index where the left index is less than the right index. And if you're thinking about why you would do that, it's because just given the two constraints, it must be, you want to form a new word, and that word must be greater than the original word lexicographically, and then it must be smaller than, it must be the smallest word that meets the first condition. So it must be the smallest word that is larger than the original. And so the way you would create the smallest word that's greater than the original, and if you didn't swap, you would literally just increase the value of one letter, like the rightmost letter, by a single value. So if you had something like, you know, HKDC, you would make the last letter C equal to D, and that would be the smallest one, right? But we are swapping, so but what that's basically telling you is you want to make the smallest increase, and you want to do that to the rightmost letter that's possible. So when you add in the factor that you're swapping letters, you're going to want to swap the rightmost letter that is less than any other letter that is to the right of it. With the way that this problem works out, and I didn't see this until after the problem was over, is that if you have any amount of numbers, or smallest change will always be the first time you see a letter to the left be less than a letter to the right. That'll be the, you'll make a swap as soon as you see that. For some reason I didn't realize that and went a different route. I tried to keep the maximum letter that had been seen at that point, but the maximum letter will always be up until the point that you do see a letter that is less than the letter before it. The maximum letter that you will see is the one you are currently looking at. Because otherwise you would have ran into a situation where your leftmost letter is less than your left pointer minus 1. And so there was no reason for me to keep track of like a maximum value, basically. Once you find the letter that is the smallest swappable one, you start at the right and you move left until you find a letter that is both greater than the letter at the left pointer. Well, actually, just that condition alone literally just start at the end of the array and move left until you find a letter that's less than the value at the left pointer. And I want to mention something is that once you find the value at the left pointer, like the one that should be swapped, everything to the right of that is already in strictly decreasing order. That's why you can say confidently the first letter that you find that's greater than your current left pointer is it is the smallest element of that subset. So once you find that, you would make the swap. Once you make the swap, then you can take all of the values to the okay. So once you make the swap, you can take all values to the right of your left pointer, and since they're already in strictly decreasing order, you can just reverse the array, and that'll give you the absolute smallest possible value that could be made from one of these strings. And I think that's most of the trick to the question. I think everything past this point is just kind of pointless. Yep. All right, that was a long-winded video. Have a good day, guys.